Hi there. Hope you have a fantastic day today. This lesson, I will go through 2021 HSC papers. Of course, there is the PDF versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. Question 29. On the day that Megan was born, her grandfather deposited $5,000 into an account earning 3% per annum compounded annually. So we do not need to change the interest because it's compounded annually and 3% per annum. On each birthday after this, her grandfather deposited $1,000 into the same account, making his final deposit on Megan's 17th birthday. That is, total of 18 deposits were made. So keep that in mind. So we need to show that A3 is this amount. And we know that AN is the amount that in the account on Megan's nth birthday. So keep that in mind. So A3 means on her third birthday. Okay, so we just need to work it out. So first of all, on her first birthday, so that means A1. So at the beginning, she was born, she already have $5,000 in her account. And a year later, that is her first birthday. So that this means that this had the interest of 3%. So her final amount for this is times by 1.03 because I is P bracket 1 plus R power N. Okay, keep that in mind. And then she has another $1,000. That is her grandfather deposit on her first birthday. So that is the amount that in her account. Then A2. So A2 is equal to now A1 with the interest on top. And the interest is 3%. So the amount for this is times by 1.03. And of course, her grandfather deposit another $1,000. So that is A2. So let me expand this. So in another word, A1 times 1.03. So if this times by 1.03, so that will give me, so I just write in here. So it times by 1.03. So that means this time together give me 5,000 times 1.03 square. So that is 5,000 times 1.03 square. And this time together, so that will give me 1,000 times 1.03. So this here is this one here, okay? So now we just need to write down at $1,000. This is this one here, okay? So keep that in mind. Let me just clear this first. So there you go. Then we need to work out A3. So A3 will be A2 amount and with the interest of 3%. So that means the final amount will give me 1.03. And then we add 1,000 because her grandfather deposit another 1,000. So that's it. Then A2 times 1.03. So this is just times by 1.03. So same process. So let me just write this down. So this will give me 5,000 times 1.03 cube. We add 1,000 times 1.03 square and we times by 1.03 with 1,000. So give me 1,000 times 1.03 and we add 1,000. So there you go. So what I do, I just put that on a calculator. So I just go 5,000 times 1.03 cube and we add 1,000 times 1.03 square. We add 1,000 times 1.03 and we add 1,000. So there you go. $8,554.54. Correct to 2 decimal place. So that is equal to 8,000 $554.54. There you go. Question 29. On her 17th birthday, Megan has this amount. After the final deposit is made, Megan then decides to leave this amount in the same account with the interest of 3% per annum and compound annually. On her 18th birthday, she withdrew $2,000 from the account. And on each birthday after this, she withdraws $2,000 from the account. How many withdrawals of $2,000 will Megan be able to make? So first of all, let me make A1 is her 18th birthday. Okay. So on her 18th birthday, that starts from A1. So on the 17th birthday, she had this amount. So obviously 18th birthday, she will have that amount plus 3% interest on top. So therefore, the final amount is this. $30,025.83. And she have interest on the top of that. So the final amount would be like this, 1.03. And of course, we withdraw $2,000. So we minus 2,000. So there you go. This is how much you have at the end of 18th birthday. Okay, keep that in mind. So for the 19th birthday, so she will have A1 and then interest on top. So 1.03, that's how much she have. And she withdraw $2,000. So this means that A1 times $30,025.83 we times by 1.03 square, because this one here I just times by 1.03. Okay, so that would give me minus this time together 2,000 and times by 1.03, and that's done with this. Now we just minus the 2,000. Let me just clear this first. So that means minus 2,000. Okay, so that's how much she have at the end of second year. That is the 19th birthday, if you like. So A3 is A2 and with the interest on top. So that's how much she will have. And then she withdraw another $2,000. So now let me just write this out. So expand the A2 times 1.03. So that will give me 30025.83 times 1.03 power of 3, because this one here we times by 1.03. Okay, keep that in mind. And let me just clear this first. So that will be minus 2,000 times 1.03 square. We minus 2,000 times 1.03. So this bit here is this one. Then we need to minus 2,000. So this 2,000 here, don't forget. So we minus 2,000. So let me just rewrite this with taking out the negative 2,000 out. So that give me 30025.83 times 1.03 power of 3 minus, I take the negative 2,000 out. So 2,000. And that leave with me 1.03 square minus 1.03 plus 1.03, and we plus 1 because we divide by negative 2,000 because we take negative 2,000 out. And let me just rewrite this series in increasing order. So let me just clear this. I write this on top of this. So that becomes like this. 1 plus 1.03 plus 1.03 square. Okay, so you can see the series easier. So now, if we have AN, and this is A3, don't forget. Now, the pattern here, if this is power 3, this is power 3. So if this is N, so it should be power of N. So that is equal to 30025.83 times 1.03 power of n minus 2000 1 plus 1.03 plus 1.03 squared and plus. Now, don't forget, because this is power of 3 and it give me power of 2. So therefore 1 less. So that will give me, instead of power of n, is n minus 1. So 1.03 power of n minus 1. So that's how it is, okay? So there you go. Now what we do, we just simplify this one first, okay? This is the series, and we know that the rule is S of n is I, r power of n minus 1, and r minus 1. And we know that a is 1, so we just write in here. So S of n, 1, 1, and we can just ignore that. R is 1.03 power of n minus 1 over 1.03 minus 1 is 0.03, if you like. So now let me just rewrite this. So that will give me equal to 30025.83 times 1.03 power of n minus 2000 times the bracket, 2000 times this, over 0.03. So let me just write in different color so you can see. So 1.03 power of n minus 1 over 0.03. So what I do now is I just use a calculator to simplify this. So make it a nice number, okay? A whole number, okay? It's look nicer, that's all, or simpler. So I just go 2000 over 0.03. There you go. Shift SD or SD button. So now 200,000 over 3. So let me just rewrite this out. So that will give me equal 3 minus 200,000 times 1.03 power of n minus 1 over 3. So we know that at the end, that is an is equal to 0. We need to work out how many $2,000 withdrawals can she make. Okay, so what we do, we make an is equal to 0. So that means 0 is equal to now let me just get rid of the 3. So I times 3 on every term. So 0 times 3 is 0. And we have $30,025.83, and we just times by 3. So I just go 30025.83, I times 3. So there you go. 90077.49. So 90077.49 times 1.03 power of n, we minus. So this term here, we times 3, so that 3 cancel out, don't forget. So that becomes 200,000. 1.03 power of n minus 1. So now what I do, I just remove the brackets. So this means that 200,000 times that. So that will give me 0 equal and negative 200,000 times 1 will give me 200,000. But it's positive, okay? So there you go. So what I do now is to just collect this like term, okay? So these two are like terms, so I just minus it from each other. So I just go answer minus 200,000. So there you go. So let me just write this down. So 0 equal negative 109922.51 times 1.03 power of n at 200,000. Now what I do, I move this on this side so it becomes positive. So that will give me equal to 200,000. So what I do, 200,000, I divide by this number here, that is 109922.51. I divide this by 10992251. So I just put on a calculator. So I just go 200,000 divided by the answer. So there you go. But the answer should be positive. So let me just times by -1 first. So there you go. So 1.819 and so on. So that is 1.03n is 1.819 and so on. So I take log on both sides. So that means ln of 1.03 power of n is ln of 1.891 and so on. So, but are you log low? So the n can bring in the front here. Okay, so keep that in mind. So now I just divide by both sides by ln 1.03. So I just go ln answer and I divide by ln 1.03. Close brackets. So there you go, 20.25. Correct to 2 decimal place. So n is 20.25. So this means that it's 21 withdrawals because withdrawals of $2,000. So 20 times, okay? So 20 withdrawals if you like. So therefore 20 full withdrawals. So there you go. Question 30. So first of all, we need to know that f of x, that is capital F. Don't forget. It means cumulative distribution functions. So that is equal to integrations from a to x. So a is the smallest value. So the smallest value is 0. Okay, to x. F of x. The question is, how long should the light bulbs work according to Jen? And we know that they will work for longer than exactly 99% for all light bulbs. So in another word, the probability is equal to 0.99 or f of x is 0.99, which means this is 0.99. Okay, keep that in mind because it's 99%. So now what we do, we just solve for x. X is the number of hours. Okay, so we know that this is 0.99 and the functions is this. So now what I do, I just go 0.99 equal 1 minus e to the negative 0.01x. So what I do, I just move this on this side and 0.99 on this side. Okay, so that becomes positive. So e negative 0.01x is equal to 1 minus 0.99. And 1 minus 0.99 is 0.01. So what I do, I take ln on both sides. So that means ln e to the negative 0.01x equal ln 0.01. Of course, these two cancel out. So that will give me negative 0.01x equal to ln 0.01. So I divide by negative 0.01 on both sides. So x is ln 0.01 over negative 0.01. So that will give me, so just go ln 0.01 divided by negative 0.01. So there you go, 460.52 hours, correct to 2 decimal place. So 460.52 hours. So 460.52. So therefore, 460.52 hours. So there you go. Question 31. So the question is, we need to find the equations of the two tangents to this function here passing through the point 3, -8. But first of all, we need to find the equation of the tangent at point 8 a squared minus 1 first. So to find the equation of the tangent at that point, so we need to find the gradient first, okay, at a squared minus 1. So step number 1, to find the gradient, we need to differentiate the functions. So y is x squared minus 1. So we differentiate this. So y dash is 2x. And we add a squared minus 1. So we need to find the gradient at that point first. So when x is a, so this means that the gradient is 2a. Now we need to find the equation of the tangents at a squared minus 1. So to find the equation of the tangent, y minus y1 is mx minus x1. So what it means is this, okay? So we have a parabola like this, and this point here is a squared minus 1, and we just need to find the equations of the tangents, okay, at that point. So that's what that meant. The equation of the tangent at this point here, a squared minus 1. Let me just find this first, okay? So now we have y minus y1 is a squared minus 1. So more than one term. So I close bracket. So a squared minus 1 equal to m. M is 2a. X minus x1. x1 is a. What I do, I just remove the bracket first. So y minus a squared plus 1 equal 2ax, and 2a times negative a is minus 2a squared. So what I do, I just move these two terms on this side. Okay, so let me just clear this first. So this become y equal 2ax, and the negative a on this side become positive. So minus 2a squared plus a squared become minus a squared. And positive 1 move on that side becomes minus 1. So there you go. That's equations of the tangents. Okay, so this equation here. That is, we just find. Okay, keep that in mind. But now what happened is we need to pass through the point 3, -8. So 3, -8 is somewhere here. Okay, just 3, -8. It's just a representation of it. Okay, the diagram is not accurate. So keep that in mind. So when x is 3, y must equal to -8. So we can substitute to the tangent equation so we can find the value of a. So when x is 3, y equal -8. So -8 is equal to 2a, x is 3, so lots of 3, minus a squared minus 1. And this means that -8 equal to 2 times 3 give me 6. So 6a minus a squared minus 1. So now I just move everything on this side. So -a squared become positive. So a squared and minus 6a. And then the 1 move on this side. So -1 move on this side. So minus 8 plus 1 is -7. And that's equal to 0. So let me just factorize this to solve for a. So we have a negative here. So we have 1 plus 1 minus. So a plus and a minus. And two numbers timed together give me 7. And the difference is 6. So it should be 1 and 7. So 7 is on the negative side because minus 6. So that is 7, that is 1. So therefore, A is -1, A is 7. So we have two answers. So this means that we already found the equations of the tangents is this. We already found it here. So now what we do, we just substitute the value A in, and we should have two tangents because A is equal to -1 and A equals 7. So if A equal -1, so the tangent will be this. Let me just write A equal -1. So y equal to 2 times A. So 2 times -1 is -2. So that means minus 2x. And minus, so -1 square. Let me just write this down. -1 like square minus 1. So therefore, the first equations of the tangent is this. So minus 2x and -1 square is 1. Like this. So therefore, y is -2x minus 1. And when A is 7, and we substitute in this to find the another equations of the tangents. So that means 2 lots of A means 2 lots of 7x. Minus 7 squared, 49, and minus 1. So that means y is equal to 14x minus 50. So let me just rewrite this out. So therefore, y equal to -2x minus 1 and y equal to 14x minus 50. So there you go. This is the two equations of the tangent that's passing through point 3, -8. Question 32. Table 1 showing percentage of females in this city shorter than 75 centimeters is 97.5%. And 160.6 centimeters is this. And table 2 showing the mean and the standard deviation for both males and females. So what we can do is we can find the mean and the standard deviations of female from table 1, and we can just convert into this table here that will help us to find the mean and the standard deviations for males. The question is this. A selected male taller than 84% of the populations, by labeling the normal distributions on this curve below, calculate the height of the selected male. So first of all, we need to understand exactly what this means, okay? So for male, let's say, let me just draw here. That's a question asked. So this is the mean. And we need to find the x values. So the x values is above this, okay? So keep that in mind. And this is altogether is 100%, don't forget. And it's 84% of the population. So the male is above 84% of the population. So we need to find the value of this, okay, for males. So to work this out, first of all, we need to work out the mean and the standard deviations for female first from table 1. So for table 1, so first of all, if you think about it, okay, for females, so the mean is right in the middle, of course, and above the mean and below the mean, which is one standard deviations, -1 and 1, is 68%. So if I halve that, of course, this is 34%. And this is 34%. And if Z is -2 and 2, that give me 95%. So I just go 95 minus 68 and I divide by 2 because I need to work out percentage on each strip. 95 minus 68 and I divide by 2. So there you go, 13.5. So 13.5%, 13.5%. And between -3 and 3, that is Z score, is 99.7%. So I'll minus 95% because between -2 and 2 is 95%. So I just go 99.7 minus 95 equal divided by 2. So 2.35. 2.35% and 2.35%. And we know that altogether is 100%. So what's left? It would just go 100 minus 99.7 and then we divide it by 2. So I just go 100 minus 99.7 divided by 2. So 0.15. So there you go. Now what we need to know is this. So the probability that less than this is 97.5%. So less than, okay? So somewhere, this region here, somewhere, okay, that is shorter than 175. So let's work this out. So we just add these probability together. And we know that this one here is already 50. So if we add 34, so that gives me 84. And if we add this, so let's just work it out. So 84 plus 13.5. So there you go, 97.5. So 97.5 is spot on. See, there you go, 97.5 here. So now, so that is, the X score is 175 centimeters. Let me just clear this first. So that's what that meant. And then we know that shorter than 160.6 centimeters is 16%. So shorter, that means this region here somewhere, okay? So what we do, we just add them up to 16%. 0.15, we add 2.35 equal, we add 13.5. So there you go, 16% is on this bit here, okay? -1 is the Z score. So that is 160.6 centimeters. So therefore, we know that this is one standard deviation below the mean, one standard deviation above the mean, another one standard deviations. So that means 3 standard deviations between this gap. And from 160.6 to 175 centimeters. So we just need to work out the standard deviations. So 3 standard deviations, let me write this down. 3 standard deviations is equal to, we just need to find the gap in centimeters. So that is 175, we minus 160.6. So that will give me, so just go 175 minus 160.6. So 14.4. So therefore, one standard deviation is, I just divided by 3. So answer, divide by 3. So there you go, 4.8 centimeters. So this means that 4.8 centimeters is one gap, okay, one standard deviation. So to work out the mean, so we just go 160.6 at 1 standard deviations. So I just go, the mean is answer plus 160.6. So there you go, 165.4. So let me just write this down. So the mean is equal to 160.6, we add 4.8. So that will give me 165.4 centimeters. So don't forget, okay, let me just write this down so you can see it. So 165.4 centimeters. That is the mean, okay? Then the standard deviation already worked it out. The means is already worked it out. That is for females, okay? So I can write females here. And then to work out males, so let me just draw a line here. So for males, so the standard deviations is equal to, from this table here, okay? So 1.1 times the standard deviations of female. So 1.1 times 4.8. So I just go 1.1 times 4.8. So that is 5.28. 5.28. And then the mean is, so the mean is 1.05 of the females. So just go 165.4 times 1.05. So 1.73.67. So let me just write this down. So that is 1.05 times 165.4. So that gives me 173.67 centimeters. Now the question is, we need to find the value of x, this x here, okay? That is more than 84% of the population. So more than 84%. So let me just draw a chart for this. So this is what it means. So this is, the mean is 173.67. And we know that this is 1 standard deviation above, 2 standard deviation above. And we know that this is 34%. And this is from previously and 13.5%. And so on. And the next one is 2.35. And we just need to work out how many standard deviations away from the mean so we can work out the x value, okay? So now we just add this up. So we know that this is already 50%, and we just keep adding until it reach 84%, okay? Keep that in mind. We already know this is 50%, so if we go 50, we add 34%, so that gives me 84%, correct? So in another word, it's just 1 standard deviations above the mean. So therefore, okay, this is the x value we're after. So keep that in mind. So this means that 1 standard deviations above the average. So this is the one here. So we go 173.67. We plus 1 standard deviation. So that is this. So 5.28. So that will give me, so I just go 173.67 with plus 1 standard deviation. So 5.28. So there you go, 178.95. 178.95 centimeters. So that is the answer. So there you go. Thank you so much for watching. Bye.